Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho, and today we continue to explain binomial expansion in Pure Mathematics 4, and we are in example 2 on page 32, whereby we are told to find the binomial expansion of 1 minus x raised to the power 3 and 1 over 1 plus 4x squared up to and including the term which has x cubed, and state the range of values of x for which each expansion is valid. And because you can see in this particular part the index is a fraction, and this second one the index is going to be a negative because it's going to appear at the numerator, we can only use this method, this approach, 1 plus nx plus n minus 1 x squared over 2 factorial plus n minus 1 n minus 2 x cubed over 3 factorial. And what we have here is our n is a third and our x is negative x, of course. So 1 plus a third times negative x minus a third x plus a third, which is n minus 1, you get because this is n, then n minus 1 x squared over 2 factorial plus n minus 1 n minus 2 x cubed over 3 factorial. And this is the last term you are expected to find, because we are told to find up to and including the term that has x cubed, and there we are. So all we need to do is to just clean up this one. A 1 minus a third x, this is term 2, plus this is n times n minus 1. N minus 1 becomes a third minus a third minus 1, it gives us a third minus 1, it gives us minus 2 over 3, which is this one, minus 2 over 3, which is that one, and of course x squared over 2 factorial here. And the other one, we're going to have a third, which is n minus n times n minus 1 n minus 2. And as much as we know n minus 1 to be minus 2 over 3, because we had that term in the previous operation, let us confirm what is n minus 2. And n minus 2 is simply a third minus 2, which is minus 5 over 3, which is over here. And all we need to do is just to multiply that out and get one term to represent the whole of this, of course x cubed over 3 factorial. All we need to do is now clean up this one, and a 1 remains 1, minus a third x remains minus a third x, but there is something to do with a third times minus 2 over 3, which is, let's see, a third times minus 2 over 3, which is equals to minus 2 over 9, minus 2 over 9, minus 2 over 9 now is over 2 factorial. That means divide by 2 or times a half, because 2 factorial is 2 times 1, so times 1 over 2, which gives us minus a ninth, and this is what we have, and x squared follows. When we talk about a third times minus 3 over 2, there's a third times minus 2 over 3 times negative 5 over 3. This is simply 10 out of 27. 10 out of 27 is over 3 factorial. So we'll be talking of divide by a sixth, because 3 factorial is 2 times 3 times 2 times 1, which is a 6. So times 1 over 6, and that is it. It's going to be 5 over 81. And at that point, because we have this x has always been negative. X has been negative. This positive multiplies out with this negative, because x cubed is a negative, so we have minus 5 out of 81 x cubed. And that is just like it. So finally we're going to have something that looks like 1 minus a third x minus 1 over 9x squared minus 5 over 81 x cubed. And the expansion is valid as long as the modulus of this term, as long as the modulus of this term is less than 1, the modulus of that term is less than 1, and it's just for modulus negates the negativity, so x modulus is less than 1, the term continues to be very valid. If you look at part B, I don't know whether we could explain it in the same video. If you look at part B, and I wish, I don't know whether we can explain the same video, but I need to bring on another video because this one is already 7 minutes. So please follow and make sure that it gets to your mind that expansion, when the index is not a natural number, then we have to use this